question number 2 is definitely a tricky question. It says, a misshapen lump of metal is weighed in air and then weighed while immersed in oil of density 800 kilograms per meters cubed. So the oil density is equal to 800 kilograms per cubic meter. It says if the weight in air, so weight in air is equal to 2.2 kilograms, and the weight in oil is equal to 1.2 kilograms, calculate the density of the metal. So the first thing we need to do when we look at this question is know what's called the apparent weight formula. And the apparent weight formula is the weight is equal to the density of the object minus the density of the fluid times the volume times gravity. So this is the most important equation you need to know. And we actually have to use it twice. We have to use it once for air, and then we have to use it once for when it's in the oil. So we have to say the weight in air is equal to the density of the object minus the density, air is a fluid, times the volume times gravity. Well, we know that the weight of air is 2.2 kilograms. And we don't know the density of the object. And the weight of air is like 1.2 kilograms per meter cubed. So we're just going to say that it's negligible. We're not even going to worry about it. And then we're going to multiply it by the volume times gravity. And then we have the weight of oil, which is equal to the density of the object minus the density of oil times the volume times gravity. So here we have 1.2 kilograms equals the density of our object minus 800 kilograms per cubic meter times V times G. So we have two equations, equation 1 and equation 2. So essentially we have two unknowns. We have V, which is the volume. We don't know the volume of the misshapen lump of clay, and we don't know the density of the object. So what I go ahead and do is I set up another system of equations. So I'm going to solve for V, and then I'm going to go ahead and plug it into our second equation. So 2.2 kilograms divided by 9, we'll just call it G because it'll end up canceling out anyway, divided by the density of the object. So that's V. So now if we want to set this one for V, it's going to be equal to 1.2 kilograms divided by G divided by the density of the object minus 800 kilograms per meter cubed. And you can see here that the G's end up canceling out. So we have 2.2 kilograms over the density of the object, or the metal, is equal to 1.2 kilograms times the density of the object minus 800 kilograms per meter cubed. So now we have to cross multiply, and it says 2.2 times the density of the metal slash object minus 800 kilograms per meter cubed is equal to 1.2 times the density of the object. So here we have, we'll call it the metal just to be consistent, 2.2 density of the metal times 2.2 times 800 is 1,760, so minus 1,760 kilograms per cubic meter equals 1.2 times the density of the metal. So now if we want to solve for the density of the metal, we need to go ahead and subtract 1.2 from 2.2 and add 1760 to the other side. So 2.2 minus 1.2 is just equal to 1, so the density of the metal is equal to 1,760 kilograms per cubic meter. So this question is definitely a little bit tricky because you have to recognize that you need to solve with the apparent weight formula, and you have to do it twice. You have to do it once for the air, and you have to do it once for the oil, and then you have to set the two equations equal to one another, and you get answer choice A for question number 2, 1,760 kilograms per cubic meter.